All right, so sequences, I've got some vocab here. Sequences, this is a sequence. You can see I have it in braces here. I put them all in blue because they're actually the outputs in a relation. Okay, the term, this is the first term of my sequence. This is the second term, the third term, the fourth term, and the fifth term. And this is a finite sequence. It has 5 terms. Finite sequences have a beginning. And so this sequence can be represented in a table. These are the same thing. This has an input. The input's 1, first term. It has an input. This is the output, as you can see right here, but it does have an input. So we still have domain. We still have range, even if it's written in braces in set notation. Okay, so it can be represented in a table. It can be represented in set notation, and as we saw before, represented as an ordered pair. Okay, all 3 different ways to represent a sequence. Now, some of you already know about functions. You know that really well. This says because a sequence has exactly 1 output for each input, it's a function. Okay? So yes, these are functions. It's just that the domain is not all real numbers. The domain is natural numbers. And that's what we brought up here. Domains, the term numbers, and then the terms themselves are, this would be first term, this would be second term, this would be nth term, and I would read that a sub 1, which means what is the first term. A sub 2 means what is the second term. So if I have this sequence right here, 1, 1, 2, 3, 5, this is a famous sequence, which we'll be looking at more on Thursday. The first term is 1. The second term is 1. The third term is 2. So a sub 1 is this. This is red. What's the second term? The answer is 1. What's the fifth term? The answer is 5. Okay. So term numbers, those are your inputs, and then terms. And if we're asked for the nth term, it's a sub n.